We have a lot of ones who are not familiar with this group, so we will have a short introduction to this group. So the IG is endorsed and recognized since August 2019. We had our kickoff meeting in October 2019 at the plenary of Helsinki. And in this kickoff meeting, we were discussing about 4 possible focus groups. One was about engineering and open science. Another one was on engineering specific DMP. And 2 others were metadata in engineering as well as data annotation. On 2 of the topics, we made further progress. One was the metadata for engineering part, and one was the engineering specific DMP. So we had an online seminar series on the metadata and a joint session with the IG metadata in Breakout 5 at the plenary here, and the engineering specific DMP also had a breakout session in Breakout 3 with the discipline specific guidance for DMPs. And now I will hand over to Paula, who will explain us a bit more on the online seminar series.
Yeah, so as Daniela said, as part of our work, one of the focus topics that we work on is metadata. And the idea of this online seminar was, first of all, to explore together with the engineering research communities, what are the challenges to be solved, how we can work together in solving them, but also to know what is there. I think there are some things happening regarding metadata standards in engineering, or research groups in engineering also establishing workflows, but it's not very well known. So the topics that the series was about was data annotation, metadata standards, and metadata tools. We had 5 online seminar sessions with in total 11 speakers, which we thank a lot for it, for dedicating time for this. You can find all the presentation and recordings of the session in our repository in the RDA website. Next slide, Daniela. And just to share some reflections on what it was discussed in these sessions, some of the people that are here today were on those sessions. And we could see that there are already initiatives developing metadata standards for engineering, working together with research groups, or those are initiatives from support staff at institutions working with researchers on that. So for me, one of the questions is, how do we make those standards more visible, that they get to known by other members of the engineering communities, and to be able to improve them, to adopt them, to update them, etc. And then, although we could explore some tools, we still see that there is a gap between selecting a metadata standards and embedding them in data sets and workflows. There are kind of generic tools there, some under development and so on, but how can we help researchers once they have decided which metadata standards to use in engineering? How do we help them to implement those? So there was an idea that it was kind of welcomed by the people assisting to these seminars, to prepare use cases maybe on those groups that are already implementing tools, or embedding metadata in their workflows, etc. So if you are interested to participate in any of these activities, online seminars, or collecting or brainstorming what kind of use cases we could have, please contact me.
Thank you. And the other focus was on the engineering specific DMP, as I mentioned before, which is now part of the hopefully new upcoming working group on discipline specific guidance for DMP. We saw that every discipline has to overcome the same challenge. You have different perspective on the DMP concept. from the funder side, from the researcher side, from institutions, from RDM support staff, and so on. And mostly it doesn't fit to the researcher's needs. The discipline-specific guidance is one of the approaches to overcome these challenges and make a DMP a useful element for daily work. In the working group are different disciplines. So we have behavioral, educational, and social science, as well as the engineering and the natural science and life science here as well. So we identified some stakeholders like researchers, data stewards, and so on. And in our BOF session, it became really clear that we need the communities for the progress. We also fixed some milestones already, where you see that in this first two milestones, the community involvement is really important. So at the moment, the case statement is under tab review and community review, and yeah, we hope for a good feedback here. And this was the short update from the group activities. And if there are not any questions, I will hand over to Gretchen. So there's in the chat something. Ah, okay. Okay, then Gretchen, it's your turn.
Okay. Let me see if I can share my screen.
We don't see you in camera. Is that on purpose, Gretchen?
I just turned my video back on, so hopefully you see it. See me now. Okay.
Yeah.
So I'm going to try to share my screen. Okay. So are you seeing the first slide on data provenance?
Yes, we do.
Okay. All right. So yeah, thank you. Thanks everybody for joining our session today. And I'm going to start off a series of presentations. And this is a brief introduction to data provenance, which is an area of interest, a strong area of my own interest. And I'm interested in particular with RIG in understanding what possible use cases we can further explore in RDA related to engineering and provenance applied to engineering. So I'm going to talk just briefly about what the basis is of provenance. I'll have a couple uses and examples, and then in our breakout session, this is something that there's a couple topic or questions that we can just talk about a little bit more. Just to begin, introducing provenance, and this is the description that is provided by the W3C Provenance Incubator Group, that it's a resource, a provenance of a resource is a record that describes entities and processes involving in producing or delivering or otherwise influencing that resource. And I just showed here a couple picture examples of things that I felt were a little bit oriented toward engineering. And you have glass materials and glass manufacturing, and then you're producing, you know, very elegant architectural windows. And then in the lower left-hand corner, you know, there's a picture of biomedical engineering with the COVID and all the engineering and laboratory work going on and producing a vaccine. So provenance is all around us and very critical to a lot of the research that our disciplines in RDA relate to. What I have done in this slide is to just capture a few of the key aspects that I think are really important in related to engineering provenance. These are pretty common sense and practical, but they're very, very important concepts to understand when looking at provenance. So, of course, and coming from a metrology institute like NIST, traceability is very important. So in engineering, most commonly you have sources of information, sources of materials or samples, even simulations, and you're putting them into a very complex process and generating a product. And you need to understand all along the way what kind of transformations were performed on those sources that resulted in the product. In the concept of reproducibility, if you're doing provenance, often you want to be able to reproduce the results, and so you can create a mapping that supports reproducibility. I've also learned that there's a distinction between this idea of capturing workflows in provenance, and in general, the terminology of a workflow is considered more of an abstraction, and where provenance is actually capturing what specific steps were executed. And that may be using an abstract workflow, but you may not, they're not synonymous. Another thing that's really important with provenance is if you want to understand for a product, what was the analysis performed? And so provenance can serve to describe analysis, which can be a complex series of steps and methods that were used to produce a particular analytical result. And then the last two things that I'll show you later an example is in integrating standards and using machine readable, syntax and semantics are all very important to provenance. I wanted to introduce just to, I won't get into this with the rest of the slides, but there are some more advanced concepts associated with provenance, and there's a researcher, Yolanda Gill, at USC that has been doing some really interesting work along these lines of talking about meta-provenance, and which is an even higher level of abstraction, and you can use it in conjunction with just basic provenance, but it gives you more information about for these actual steps that were conducted in a provenance, what were the driving rationales? What was the motivation to performing the steps that you performed? And if you are using certain kinds of templates, what strategic choices did you make in choosing particular aspects of a workflow and creating templates, and also things like semantic workflows to come into play. Provenance also depends often on external sources of information like work IDs and DOIs are just one example of things that you need to factor into describing a provenance at this meta-provenance level. And then also, if you're implementing really complex modeling, especially in engineering, you may want to understand how to represent those models. They may have this whole other complexity in of themselves, and what constraints did you apply to those models? So moving forward and just talking about, what standards exist, and I'm not, for time's sake today, we don't have time to get into everything, but the basic standard that most people are starting with when it comes to provenance is the W3C PROV model. And the really interesting thing about this PROV model is that it sets the stage for defining relationships between the primary structures. You're trying to produce an entity, what activities were performed to do that, and what agents you know, were used to orchestrate the production of the entity. And so the most important thing with provenance is this idea of all the relationships between these three core things. So that's shown in the left. Over on the right is just taking that basic PROV model, and I don't get into the details of different types of entities, but just showing in a basic engineering workflow how you can extend that to an engineering provenance in a very basic capacity. So in engineering, you may, again, have as your agent, your provenance agent, a particular tool or a workflow, and you're trying to produce a component in using this workflow. And in order to produce that component, you have to execute certain kinds of processes or activities along the way. So again, you can see from this very basic extension of the PROV W3 PROV model to the engineering, you know, correlation, how that might work. So I'm just going to assert that, you know, if you look at just the very basic definition of engineering, and it's, you know, applying science or knowledge to design, build, and or maintain a product or a process to solve a particular problem and fulfill a need. And if just reading what the definition of engineering is, there's just almost a complete overlap in that concept with what provenance is. So I'm just going to assert that provenance is really core to engineering, and most engineers are already performing some kind of provenance type of workflow and model in order to conduct their work. So it's, you know, and related to RDA with research data management, which is fundamental. The research data and provenance, or excuse me, engineering, it both, let me back up just to my point here, is that science in itself, you know, both drives and relies on engineering, okay? And the two are very tightly coupled. And this is just something I crafted in thinking through these slides. And the integrity of science through engineering processes really depends on provenance. So it's just very key, very critical and important. And in terms of research data management, you know, I'm really hoping to see us, you know, make much better use of some of these standard capabilities with provenance. And again, just looking at engineering systems and systems engineering in general, that there's a very strong dependency on what are requirements and what is design. And again, that all feeds into developing provenance in research data. And you have to understand in systems engineering, basically, what are the types of interfaces which translate to relationships in provenance. And the other thing with engineering is engineering also, with all these interfaces, you're often crossing boundaries between multiple different types of components and systems. So just putting a little plug in for FAIR.
Sorry to interrupt, Gretchen, but we have one more minute only.
Okay. And I'm just going to jump ahead then. There's a couple key points here for our engineering use case concepts, but I'm just going to show this is a wrap up, and this is a use case where we're taking, this was developed by a German aero engineering facility, where they take the basic provenance model, and they develop a standard data model where when they're performing their workflows, this data model allows them through APIs to store both the data and both of the provenance record. And it's a very nice and elegant way in which they're applying provenance, and it's for how they're going to build aircraft engines. And just the takeaway from this is, for the sake of time here, that in their implementation of provenance in this engineering example, in this data model, they were able to determine what the inconsistencies in traceability were in their design that allowed them to solve problems in the design of rotor blades for their compression system and to detect inconsistencies and correct them. So I included the reference here and just want to encourage people to look at this. And it was really key with the provenance and the relationships between how they actually use the rotor blades to do their calculations, and mine through those provenance relationships to understand and optimize their aircraft engine design. So it's a great example of using data, standards, provenance, and engineering. So there's a couple questions we'll come back to in the breakout session, and I'll just wrap up with these. So we'll come back to these.
Thank you, Gretchen. I think the next one is Santos or Sibille. The idea is that we will go in breakout rooms to discuss both topics in groups. So there you will also have the opportunity for questions to Gretchen.
So it's me, I think, the next one. So I hope you see my slides now. I go in present modus. So
Perfect.
perfect. Okay. So so I'm really sorry. My background is a little bit noisy, but I tried. I want to present what we did in SimTech, the class of excellence at the moment for engineers. I'm a mechanical engineer as well, so I have a really background in mechanical engineer, but I work as well together with civil engineers a lot. At the moment, we develop an infrastructure and guidelines for the researchers. But before I joined the cluster, I worked at the library, and I'm working still there. So I have some project there as well with engineers. So I want to present some ideas and the beginning of solutions in these topics. In my opinion, the special engineering problems are the proprietary software like MATLAB or ANSYS for mechanical engineers. We have a lot of problem with non-disclosure agreements, so they don't want to publish their results. The programming is a means to an end, and especially in Germany, the engineers do not learn how to program or how to develop a software properly. And there's a missing culture of sharing. So it's not very common to share results because you can earn a lot of money with your results, and you need the money from the industry, especially in Stuttgart. We have a lot of car industry, and the institutes are very rich because they are working together with industry. Our first ideas we already implemented or tested at the institutes are the first one refers to the data provenance we heard before. Here I work together with an institute from the informatics, a data provenance institute, because one of my other research software engineers who work together with me is from this institute, and he has the idea to implement a server which automatically wrote the metadata in the files and then to publish it over the data repository. It's just the beginning of an idea. It's not working at the moment, but there we have one student at the moment who try this idea out and work together with other engineers how it works for them. Another step is that we want to educate PhD students together with professor from the Mechanical Institute. We started a lecture 2 weeks ago, so it's a very new lecture. We called it Digital Literacy in Research and Teaching. And there we have a lot of topics containing a lot of research data management topics like fair data, but as well programming with Git, or how you can better document your results. And this is just one first idea how we can implement a lecture for more students. You can see the links there. I think we have not enough time to look at them, but you can have the slides and look for yourself and see the ideas behind them. With another project we started a few, I think 2 years ago. This is from the mechanical engineering side, from the civil engineering side. They have a research software called Lumux. It's a flow simulation software, and there we implemented a visualization for the software so they can present their results better. And the next step we want to do, hopefully this year or beginning of next year, that we want to implement the visualization in our data repository so that the other researcher can open the visualization directly from our repository. And I think this is very nice because there you have really a value for other researchers, and they really want to use this and have some idea how results can be presented in another way, just not in software or in data files. The other thing we already did is this metadata schema Mgmt that we have presented, I think yesterday, so I don't say so much words about it. And we have already integrated this metadata schema in our repository, and we are discussing all the time with the researchers which metadata they want to use, what metadata fields they want to have. And we are, at the moment, we can do this. We are looking really deeply in the data the mainly engineers at the University of Stuttgart want to publish, and we really help the researcher to add a lot of metadata to the data they have in our repository. So it's a lot of work. I don't know if we can do this in the future when more people want to publish their data, but at the moment we can do this. Our next steps is to have a further development of standards like in the NFD4I in Germany. It's an infrastructure. NFD for Inc. stands for the engineering community, where we can maybe have a more broader audience for the metadata schema, for example, that it's not just at the University of Stuttgart, so everyone can use this and everyone knows about it. I think that's the main point. As I already mentioned, wanted to implement visualization in the data repository, not just for one research software, maybe for other. We hopefully we have a new project there, but I don't know at the moment if we get the money. What we already did, or what we started it, is to add the license checker in the data repository. So this project started this year. There we work as well together with another institute from informatics, and have this deployable research object you see in the slide. And there the idea is that we can publish everything together, and the license of the software in this object is checked automatically, so that other people who want to reuse the software can see if it's compatible with their license or what they want to do with the software. And what we want to do in the future is to have a better support of documentation. I think that is one of the main points, because it's very difficult to have a good documentation. You have to document for yourself, you have to document for others, and it is normally the PhD students don't have the time to do this. So I have discussed a lot with them, and we don't have a solution at the moment, but I think we develop something in the next year. As well, we want to develop a software steward concept for the university. We have at some points software stewards, but they are all in projects or do not have a stable, how can I do this? They are at an institute, but they are not their main topic, the software, but they have to do this. And we want to develop something that we want to have people who are responsible for the whole university to educate and help the researchers with their research software. And we want to broaden our program for programming skills for engineers, because I think there is the main problem, because they don't really know how to write their programs really properly. And the last point is something strategic. We try to implement in the cluster that we have a better acknowledgement for people who publish their software. So this was my slide. So thank you.
Thank you, Sibylle. We are a bit late in the schedule. Now is the turn of Santosh. So Santosh, you have 10 minutes from now on. Are you sharing your screen?
I think Sibylle is still sharing her screen. I need her to like stop before I can share it.
Yes.
Yeah.
Sibylle, we are still seeing your...
Okay, I stopped it here. So I don't know. I just stopped it.
Can you share it? Okay, I will stop it. I think for you. So okay, now I'm sharing. So now, Santosh, you should be able to share.
Yeah, thank you. Hi, everybody. As I already introduced myself, I'm Santosh Lamparthi. I'm the data steward with the Faculty of Electrical Engineering, Mathematics, and Computer Science. Though I'm a data steward there, my background is in mechanical engineering. And my presentation today, I will be drawing both on my background not too long ago as a researcher and my use of research software there, and also in my experience as a data steward, and in my interaction with other researchers and the problems they've faced. One of the things I've come to see is the fact that my own experience as a mechanical engineer and using software there is reflected across different fields, and it's not just limited to any one, say, specific software or to a specific field. So as Sibylle mentioned, there are lots of commercial software that are used within the engineering field. So you have, say, MATLAB, ANSYS, COMSOL, Cadence, SolidWorks for different things. And you have equivalent open source software. So for example, Python can be considered to be able to do the job that MATLAB does. For ANSYS and COMSOL, you have OpenFOAM, Elmer, Cadence, which is a software used in designing electronic circuits. You have KiCad, which is quite popular, and for SolidWorks, there is FreeCAD. Now, some of these alternatives are widely used, while others not so much. So, for example, Python is quite extensively used. OpenFOAM, when it comes to fluid flow simulations, is actually quite popular. Similarly with KiCad. But for example, in the case of FreeCAD, it's not as widely used as, say, SolidWorks is both in industry and for research purposes. Some of the things you want to look for in your open source equivalents is the fact that You have adequate support through a large community that is actively there, so that everybody from a learner to, if you have advanced technical difficulties, you'd be able to consult and find a solution. To see if the software is properly maintained and properly updated periodically. Again, among the ones I've listed, some of them satisfy these and others don't. Also, if the tools that are required to be used within the field are updated periodically. And finally, often one that is overlooked, especially when it is seen within the research context, is the ease of use. Does it mean that we have softwares that essentially address all of these things? Not really. I think the real problem is that at the moment, we can't avoid proprietary software, even if we want to, both in the research context and the real world. This produces a lot of problems, but I've highlighted a couple of ones. Fair data becomes very difficult. One of the reasons is, for example, the licensing associated with a proprietary software. There are lots of different licensing regimes that exist, which complicate how you can, in fact, archive your software. So, for example, if there's a student license, can it be accessed by an industry person, industrial license? Can it be accessed by a research license? Most often, when you have output that is from a research licensing version, students or, say, industry versions might not be able to access it. Then you have issues about support. This varies across softwares, but usually older versions are not supported over a period of time. So even if you have a license to a particular software, it might be that the version you need to run to be able to use a particular archived data set or particular archived model is no longer possible because support is not available. And then finally, because there are lots of new ways of delivery. What I mean by that is that we've moved away from the period where initially you just you paid for the software, you downloaded it, you installed it, and you used it as much as you needed. Now we have server licensing methods, which is then going forward into what is now becoming more popular, where software as a service. Therefore, you don't actually own the software. You essentially rent the software out on maybe the company's computer clusters. You work on the cloud and you access it. There are lots of advantages to this. The price point can be reduced, and you don't need to have expensive infrastructure to run it. But it becomes a double-edged sword, essentially, because how do you archive and use it over long term, and how do people who might not have access to that particular version access your software? And finally, you have issues with open science. How do academic institutions square the circle of wanting to promote open science while using academic proprietary software? This is not just in the context of research. These proprietary software are extremely popular with industry and are also taught to students right from the undergraduate master's level. There's a good reason for that, because if they're going to go into industry, then industry wants these students to have those skills, hence we teach them. But unfortunately, this creates a circle wherein we perpetuate the usage of these proprietary software and the closed format in which they work. And finally, you'll have to negotiate with companies to accommodate open science in ways so that you can, for example, use the licenses, maybe format solutions. I don't have ready-made solutions. The next slide, I'll be talking about what I think are possible options that we can look at and possible directions it can go. And I'm hoping that in the breakout session, we can discuss about where this can be taken. So what I think is needed to address the use of these proprietary software is that it needs a multi-pronged approach. One of the first things is that there is a need to negotiate with the providers for creating options and support archiving of these their software outputs. So essentially, for example, long-term support of older versions. So if a software vendor says, oh, we don't provide support for more than 3 or 4 years. If we are talking about archiving, a long-term archiving of at least 10 years, then this needs to be negotiated with the provider to say that, okay, if we are going to sign up and use your research software in our institution, then yeah, we would want to have support for a longer term. Licensing for archived data access. So what this means is that not only is your archived version available for others to use, but that the end user must be able to access it through their licensing. So if they have a different licensing version, they should still be able to access it. And finally, for people to be able to actually use it, if they have access to the output, the software output, they must be able to access the outputs without actually having to pay for the software. This is especially important if you are looking for these outputs to be reachable in third world countries, where the cost of these software can be quite high and not easily accessible. The other thing is that specifically fund researchers in developing the software. This is not, in a sense, completely new. So, for example, I'm talking to you from the Netherlands, and this is the land where Python was first developed by Guido van Rossum. And so researchers and people who are interested in developing these things have been doing it for a long time. But what I specifically mean here is that fields need to be identified where research software need to be developed, and that direct support needs to be offered there. Also, when offering support, it is not just about the development of the software itself. One of the points I mentioned earlier about supporting ease of use. One of the reasons commercial software is so popular in industry is the relative ease of use and the low barrier to entry, as opposed to some of the other research software that could do equivalent things. Often researchers don't see the adding of these ease of use functions as adding value to their work. And I think this can be aided by institutions and funding agencies supporting research software engineers and data managers to help them essentially transfer these software from a very niche research product to something that is more usable. And finally, taking a different direction or a different orientation in terms of commercializing open source software. So the valorization route of just, say, selling the software directly can be diverted, and a different approach can be taken where providing services, which means that the open source nature of the software is maintained, but you essentially provide either support for the software or through consultancy can be done. And this, for example, in the CFD world, in computational fluid dynamics, already exists. There are a lot of companies that provide support using open source software that do that. And I think this needs to be extended if you want to address the fact that we have engineering software that is not engineered for wide and open use. Thank you.
Thank you very much, Santosh. Daniela, are you there?
Yes. Yeah, I'm there. So, so Paula, you prepared the breakout rooms?
Yeah, so the idea is that now we go to breakout rooms and then we dedicate 10 minutes to that breakout room, discuss one of the topics, and then the other one. So one breakout room will discuss provenance, the other one software, and then we will swap. The thing is that for a weird reason...
Sorry, Paula, so the speakers will swap. So you will stay in the room?
No, the problem is that Gretchen doesn't appear in my list for assigning her into any breakout room. I don't know why, because she's in the list of participants. So we will need to, half of the people will need to go to a breakout room and the other half will stay here in the main room discussing.
Perfect.
Yeah. So after 10 minutes, I will close the breakout room. We will come into the main room and I will assign a new breakout room for the rest of the people. I hope that's clear. And I will start now the breakout rooms. All right. So Gretchen, in this room, we are discussing provenance.
Okay.
So you can take the floor for 10 minutes now.
Okay. If you want, I can just share my screen, and there were some questions that I had proposed that we could discuss in the breakout room.
Mm-hmm.
And I think these are also in our collaborative notes. So if let me think if I go here, right. So there's a collaborative notes section where I can actually type some answers for people. So for those that are still in the breakout room, the first question that I proposed that we could discuss is,
we don't see your screen. Huh? So
oh, you don't
You
see
like
it?
to
No.
share your screen?
I'm trying. Okay, hold on. You see this? Do you see it now?
We see the Google Doc. Yeah.
Yes.
Okay. Okay. So there's 3 questions here. And the first question was, are there RDA research disciplines related to engineering workflows creating provenance records? And I guess this doesn't have to be specific to RDA, but are the people in the breakout, do people have some familiarity with engineering workflows and generation of provenance records for these? We have a few people in the breakout.
Yeah.
So of those here, are people familiar with any of any other engineering disciplines in RDA generating provenance?
No, besides what we saw yesterday, but that was about metadata on provenance. We had a joint meeting with the interest group metadata, and they created this set of elements for metadata, and they are looking for collaborations to go deeper in those terms. And one of those is provenance, but I'm not aware about a specific initiative.
Yeah. So in my slides, I didn't have as much time to go into the use case that I presented. It was an aerodynamic data model for producing engine design, but it was a really, really well done design model, very nice article where they go into great details about how they actually created their metadata model for provenance and stored that linked together to the raw data and for each provenance record they captured all the relationships between their components, which were in the case of the aerospace the engine design were their rotor blades for the engine compression system. But that is one of the best examples that I've come across in engineering and a description of the actual provenance record. And they used best practice in terms of like creating a hash for each record, and any activity that affected the components in the record, they generated a new hash. They also assigned unique identifiers, persistent identifiers to each component in the system. And as they went through new activities, they would generate new subcomponents or children, and those also had persistent identifiers. So it was a very good model. I thought, in demonstration of using provenance. Okay, so I'll just move on. That was the first question. The second question, and I would really hope some people know some answers to this, are what other interest groups and working groups? We heard a little bit about the joint session we had yesterday with the metadata interest group, where they have one provenance element as part of their metadata definition that they're working on. Are there other interest groups or working groups that you're involved with that are working on provenance and that may have an interest in collaborating with the engineering interest group, or not?
Yeah, now that I see here the PIDs for instruments, I don't know if, well, they were working on use cases as well, and they do have a use case of wind energy from actually one of our co-chairs, where they create a workflow on how to trace and set up field experiments, also using PIDs to identify the different sensors and so on. I'm trying to look for it.
And I think the group of PIDs for instrument is led by Markus Stocker. So he's also an engineer working at the Technical Information Library in Germany. So he is also a member of this group.
That's an interest group, I believe, right? The PIDs for interest instruments. I'm pretty sure that's an interest group. It's not a working group. Yesterday, Rainier was talking about the provenance interest group, but I have not actually come across the provenance interest group or found something specifically focused on provenance. But
no,
it comes up in a lot of discussions, but
yeah. Is it the PTTP, the annotation group, also working on within data annotation? Maybe they are also working on provenance, but I'm not sure. I lost a bit of contact with Peter.
Yeah.
I'm Christian, so maybe I could not attend the session of the virtual research environment interest group because it was very late for me in my time zone, but I'm not sure, but I guess that for virtual research environment, so VRE interest group, they do need provenance information. Because if you have a virtual research environment, then you need to track the different processes and that you are applying to your data. So I don't know if they have considered provenance or not, but maybe it would be a good thing to see with them.
Yeah. Yeah. Now, is that the environmental research? Is that do you know the name of that that RDA group that research?
It's the VRE. I can write in the VRE.
Thank you.
It's an interest group.
Okay. Thank you.
It's Angus here, DCC. I don't know of other RDA groups, but I was wondering about the TDI, CDI standards, which has it's a new standard coming out of social sciences, which I'm aware of that, and I don't know a huge amount about it, but I do know that it has a focus on provenance, and that some of my colleagues in FairSphere are looking for participants for a pilot project to use DDI CDI with repositories, which may be a bit of a shot, but it just came to mind as something that could be interesting.
Could you repeat the name of that standard that I was just trying to catch?
DDI CDI. I'll put it in the chat.
Okay, thank you. I'll try to DDI. Okay, DDI CDI. Okay.
We have 1 minute left, then we will swap.
Okay, so again, this was a little bit more about specific about provenance generation. And this is, I mean, besides having a few standards, what are some of the best practices in provenance generation? And I saw in my example, just a reminder, assigning like unique identifiers or persistent identifiers to each of the objects in the provenance, capturing the relationships between the objects. Are there other data tooling, data models, excluding the W3C, but other best practices that anybody in the group is familiar with generation of provenance? Or tools in your experience that make provenance models exchangeable or interoperable? So that's kind of a more kind of experienced question in working with provenance data, but before some metadata was called provenance, it probably functioned as provenance. So
Sorry, Gretchen, but I need to close the room, so the people will be coming back. I'm sorry.
No problem. No problem. The timer goes off.
Yeah.
Okay, that's good. Thank you, guys.
But they will be here in a couple of seconds still. So if you have any suggestion for Gretchen, still can give it to her.
Yeah. Okay, I'll just throw down PIDs.
They will be here in 30 seconds. I forgot that it takes 1 minute to close.
Gretchen, have you ever thought about maybe the data provenance with the process of open innovation? Have you thought about the relation? Or maybe if the concept of open innovation is pushing the provenance as well? So, because we have some researchers that came up and said, okay, when I'm getting the samples from industry, we don't get the provenance with it.
Oh.
So they don't, so they get the sample, but they have no history, nothing from the sample as well. So and therefore I was thinking maybe the concept of open innovation could help data provenance to be pushed.
All right, sorry for interrupting. I will be opening the room. So the ones that were here now in the main room will be going to the breakout room with Sibile and Santos to discuss software.
Okay, thank you guys.
Oh, Paula, I think I can stay here as well.
as you
Yeah.
prefer.
I think I took my notes in Breakout 2 for Breakout 1. So I'll go back to Breakout 1.
All right. So Matias, Jose, Moran, and Onag. Oh, Onag didn't. Okay. I don't know where he went.
I'm here.
Ah, you are there. Okay. So you were discussing software before? Is that correct?
Yeah. Yes, we were.
Great. So now you are in the provenance discussion and we have 10 minutes for that. Gretchen, the floor is yours. I will have to interrupt you exactly at the 10 minutes. Sorry.
Okay, I'm gonna, thank you. I'm going to share my screen. I've kind of did it in the reverse order, so it's okay. All right, thank you guys for switching Breakout. So this is a discussion we wanted to have for data provenance, and I have 3 kind of question areas here that we were exploring. The first one is a question to you. Do you have other research disciplines, whether they're associated with another other work areas in RDA or your own research area that would be helpful for engineering workflows and creating provenance records? So this is just putting a feeler out for other research disciplines to consider for engineering workflows. So feel free to unmute yourself and share any ideas that you might have with engineering workflows.
I think chemistry could be one of the disciplines, but I think that the RDA group in chemistry is not that active.
Okay. And chemistry in terms of like engineering workflows and creating provenance for maybe in terms of like samples or history.
Yeah. Sorry, go ahead.
No, that's fine.
Actually, that's exactly my PhD work was related in such cooperation. So we provided samples for engineers to build basically demonstrators out of that. And also we did measurements for samples, or like it was a physical based group. So I think samples and measurements from the natural sciences are often precursors in a way for engineering work. Material sciences as well was somewhere in between engineering and natural sciences.
Yeah. Yeah. At NIST, where I work, the materials science community is very, very interested in provenance with preparing of a sample. They may take subsamples from that, and then whether they're doing electron microscopy or neutron, beamline studies, and then doing different analysis on those. But over time, those samples may have subsamples and all sorts of things in between. And they definitely want to track the history and the provenance of all that, how the material progressed through the research chain. Okay. If you come up with any thoughts, even after we move on to this next thing, feel free to chime in. Okay, the next question was, what other RDA interest groups and working groups maybe you're involved with? For example, like the PIDs for instruments. There's a metadata interest group we met with yesterday. They have one very high level provenance element that they're working on, they're interested in. But are you familiar with how this may overlap with the the work we're interested in engineering provenance and other groups.
So I'm part of the FAIR for Research Software working group, and since, in the FAIR principles, there is some principles that are regard provenance. We are looking at this aspect for research software. So I think that's a good working group that can, where we can have discussions on this aspect with engineering.
Yeah. We're really looking again with like our engineering research workflows, and how do you capture in the entire workflow the various software elements, and software tooling.
Exactly.
So that's okay. Any other ideas? Okay, the last question again, and if you have any other comments or questions related to provenance, feel free to chime in at any time. This is very friendly. So this is just a little bit more of an advanced question, and that is for generating provenance records or provenance information. Are you do you have any interest or any knowledge of best practices, work underway with provenance, or standards that people are implementing? The one example that I started to show at the presentation with how they were using unique identifiers or persistent identifiers for all the components. And I didn't get to talk about that too much, but it allows, and then with the relationships, they build linked relationships using identifiers in their records so that they can traverse, do like recursive queries or trace through the provenance records themselves. But I'm interested in your experience or your awareness of other best practices related to provenance.
I think that the museums are doing really interesting things here. I mean, it's quite far away from chemistry, but because they have simpler workflows. I mean, they have an object and they can assign a PID to it. But they have a lot of history doing this, which they're just digitalizing at the moment. And I'm trying to look for it now where I saved the link, because they have a project in Europe working on this at the moment with all of the natural history museums, and some botanic gardens in Europe are pooling their resources to come up with something here. And I think in certain aspects of engineering, actually, there's a lot of overlap, because often if I look at what I'm dealing with, which is maybe detectors, for example, you have these permanent objects which aren't being taken apart so much. Whereas in chemistry, you typically have samples which are quickly made and quickly destroyed, or maybe it takes years to make them, but they're not, they change over time. Whereas engineering tends to be more permanent. And I think there's interesting things going on with museums.
Okay.
Let me look for the... I just inserted into the notes a link to the SPDX specification. I'm not sure that's what we are looking for about provenance generation, but it is about software and package data exchange, which might answer that.
Okay. I'm not familiar with the spdx.dev specifications. I was really impressed with the one use case out of the German Aerospace Institute that I had explored, how they actually designed for their provenance, record. It was part of their data model, and they could actually apply their provenance model to different workflows, whether they were trying to look at how in their rotor designs, how the blades were changed, or they could look at, other parts of the materials development process, and constructing the design of their engines, and look at the provenance and figure out through this data model, navigating through this data model, what changed when. But they could apply their model to different parts of their system. So it was just a really excellent example of a data model design, data modeling that could be applied, universally. So I was really impressed with how they did it.
Gretchen, they are coming back now.
Okay.
The others. Sorry for interrupting. So
no, we're good. We're good.
okay.
So do you guys have any other last minute thoughts related to provenance in engineering, or?
I just posted a link to the Disco project, which was what I was thinking about in the chat.
Okay, thank you.
Thank you. Daniela, the floor is yours.
Gotta put that in here.
Yes, thank you. Gretchen, can you stop screen sharing?
I will stop. I did.
Perfect. Okay, wait. Here we go. Yeah. So so we have 1 more minute for Gretchen to have a short summary about the discussion, and then Sibylla and Santosh as well, 1 more minute to summarize what was coming up, what was the major points in the discussion, and yeah, maybe what was good ideas looking in the future in. So Gretchen, please.
Yeah, we looked at a couple overlaps with other RDA groups. The wind energy traceability was an interesting one. There's a new standard in social sciences, and other kinds of virtual research environments. So tracking processes applied to these as well. And chemistry came up as one where there's a lot of need for provenance. And then we were looking at other RDA IG working groups, FAIR for research software, data fabric interest group, and the PIDs interest group, that those came up as well, PTT, P data annotation.
10 seconds.
And then just some best practices we were looking at, and there was some interesting links shared that might have further exploring. Thank you.
Thank you. Sibylla and Santosh? Maybe one of you, Santosh?
Yeah, I can go. So in the breakout session, we essentially looked at 2 different questions. The first one was to see if there are any suggestions for how to say improve, have greater adoption of open source software in engineering education. And we had a lot of nice suggestions, like, for example, having students start using open source software at the bachelor level for like using things like LaTeX so that they're exposed to it. We also saw that engineering is a little bit more difficult to do than in other natural sciences simply because of the demands of industry. There were also suggestions about introducing open source software as early as possible, and also, say, for example, using senior students to provide tutorials and training for newcomers to create continuity. For the second question, we had discussions about how some companies use just limited tokens for MATLAB licenses rather than large-scale licensing. A lot of small-scale usage is also limited to tokens rather than full-fledged licenses for unlimited usage, and that a lot of other use is directed at hardware rather than the software used directly. I think that kind of summarizes our breakout sessions.
Perfect, thank you. So, and when you are interested in providing use cases and working on the subjects, here are the contacts. And why isn't it working? Okay. And also some next steps. So from the part of metadata and engineering, we will continue the online seminar series in Q1 and Q2 in 21. And we are looking for use cases. And when you are interested, please contact Paula. And also the discipline-specific guidance is looking for use cases, is looking for interview partners. So we're starting with preparing an online survey in Q1 in 21. And yeah, when you're interested, please contact us. So we hope you enjoyed the meeting today, and yeah, you will become a member of our group. So most of you were not members, so we invite you. So visit our website and join us on Slack. So we will also communicate via Slack. And last but not least, we also want to invite you to register to a conference where Paula and I were involved on openness and commercialization, how the two can go together. It's under the umbrella of CSAR, and it's on the 3rd and 4th of December 2020. So when you are interested, please register. Paula, do you like to share also in the chat the link? Perfect.
I will.
Okay, and then I hope we are in time. Yes. So thank you very much for your attention. And if you have any questions, feel free to contact us and join us, and yeah, hopefully bring more ideas, more use cases in engineering. So thank you very much.
Thank you, everybody.
Thank you, everybody.
Take care.
Thank you, everybody.
Thank you. Bye.
Bye-bye.